Hello and welcome to Advent of Code 2016. This is the December 25th problem. We've reached the end of our Advent calendar here. Let's see what the problem is. Clock signal on the roof, not much time, huge antenna, timing data, connect my stars, but it doesn't work. Clock signal. Quickly explain. You need a clock signal. Okay. This is a signal 4 o'clock. No, a clock signal. Timing information knows how to read an endless alternating pattern of, okay. The only is on top, and you're definitely not. Okay, a sem bunny, all right. Okay, pretty good. Now there's an out as the next value for the clock signal, all right. So take a look at our puzzle input. Good. Okay, what is the lowest possible integer that can be used to initialize register A and cause the code to output a clock signal of 0101 repeating forever? Okay, all right, pretty good. Let's all right, yeah, let's dig in here. So let's pull up our sem bunny code from last time. So we have our parser. So let's see, where is it? And let's see, is toggle also a thing here? PGL. So there is no toggle. That's nice. All right. So value. Okay, all this stuff. Yeah, sure. We'll just copy all this. So parse, copy instruction. Okay, all the way down to here. All right. And then what I need is situation. So let's see. So I can take out toggle since we don't need it, but now I need out. And I'm going to represent this. So let's see here. Out X transmits X. Okay, so something like value state arg A instruction. Like that. And let's see, then what? We want to do something like, so we could represent the state as also having output here. And we say conj to the output the value of that. Okay. All right, and then we're going to need a little something different. We're going to need a way to recognize that the computer has entered a loop. So let's see, repeat. So let's see, something like until looping like this, some computer, what we're going to do, iterate, do instruction like this, then something like we want to take while the states are unique. So something like I'll say something like loop states is going to be equal to this. Let next, or then so until looping, yeah. So the current state will just be the computer. Then the next state is going to be do instruction. So actually, let's do instruction in the current state. All right, and then we say, let's see, if next. So we want to say something like if this, then we know that we've entered a loop. Oh, actually, no. Let's not do it this way. Let's have. We want to just look at. We just want to look at this here. So state of computer. And if this is the case, then I think we want to say something like and clock in the output of next state like this. Let's see. So if this is the case, then we want to stop running the computer. Then otherwise, if clock this, then we would like to emit. Let's do something like true, like that. And otherwise false. We're going to say it doesn't match. And otherwise, we're going to recur on. So we want to conj into our states, the next state, and then we want to start with the next state. This is until looping here, go like this. Then, okay, so then we're going to need to implement clock, and then we basically. So how do we recognize that a computer or that the output is a clock signal? We could do something like RE matches. So if we apply str output, so something like apply str if we like this, okay, and it has to match. So let's see, 0, 1, 0, 1 repeating. So 0, 1 followed by any number of 0, 1s like this on here. Okay, so this will identify a computer that has produced a clock signal. Now what? Now we have to say for I in range, when until looping assoc starting state A, or assoc in starting state A being I. Yup. Then emit I like this, and then take the first one here, and then let's find starting state. Starting state like this. So we don't want to do that. Okay, this is fine. We are going to want to take this def our starting state. Good. Change this back to a def once. Then let's read this whole thing in, and then try running this. Okay, wrong number of args passed to assoc in. Right. Like that. Ooh. No matching clause in the do instruction. Why? Is TGL is not in here. Okay. What's up? Well, let's take a look at starting state. Good. What is the issue here? Oh, I think I know what it is. Let's let this go. Also take this out. Okay, run this whole thing. Now let's look at starting state. Much better. Now let's uncomment this. All right. Okay, don't know how to create. Let's see. Maybe. Okay, so I think I want to leave in. Don't know how to create an right. Yeah. Okay, so we have to actually put starting state. Starting state needs to have. Well, does it actually? Might as well make output be this empty thing here, and then let's make sure. Okay. Yep. Okay, this is. So this actually needs to be update output to the update output by conj being the value of state at a certain point. All right. again. No matching clause starting state? That doesn't seem right. Whoa, that's weird, and I think I know what happened. Yeah, this is one of the things about using the clipboard. Yeah, redefine this, change it back to a def once. All right. Okay, good. Get to take advantage of our multiplication optimization there. All right. Okay. And yeah, just waiting here. Let's see if we can examine the state of the computer a little bit. Doesn't look like we put any sort of debug thing in here. All right. Well, what happens if I just do this? So it looks like this is not returning. So that's not good. That's surprising. It would seem to indicate that the computer is not reaching any kind of looping. That until looping isn't getting to this point here. So states is a set, and we are checking to see if state is ever repeated. And it really seems like it should be. Let's see, if we def s to be states like this, and then so I'm going to assume that this is not working. I'll run this again. Okay, what is the count of SS? Okay, let's see, namespace. This is a lot. There's a lot of unique states. And one of them. Operator, okay. Why? So I'm surprised by this because this looks like it's including the code. But the code shouldn't be included in here. Okay, so something's wrong. I thought I was representing until looping. So state should just be the state of the computer, which I think only includes the state of the registers. That's what it looks like. All right, and then onto this. Oh, right. There we go. Okay, this is better. All right, so let's try this. It's still not working, right? All right. Okay. Oh, wait a minute. All right. So since SS has gone down, this is actually enumerating. So this is actually going up. And it seems like you might be able to put, well, actually, no. Because this was only supposed to do I. This is only supposed to go for 0. So what is up? If clock true or false. All right, let's put a little bit more into this here. Let this be I. Kick this off. Okay. All right, now let the next state be this. If we've already seen it, then get out of here. Do something like this. Yeah. Okay. All right. So this is getting out. Maybe we just needed to redo until looping here. Got it. Much better. Much better. All right. So let's do this on the whole range. Oh, wait a minute. Ooh, okay. So I'm not actually terminating at the right point here. So I'm either going to have to scan this input for the first value of true, which is okay to do, or I'm going to have to change the program. Either one is okay. I can always just start the program off at wherever. Be kind of nice. So let's see. Can I redefine? So def OOT output this, just that I can. All right. Okay. Yeah. All right. Plenty of examples of programs entering loops. Oh, you know what I'm not doing, which I need to recognize here. I need to recognize when it's in a halt state. Yeah. So something like cond. So how do we recognize a halted state here? Yeah. So if it's halted, then false. If this is the case, then okay, get rid of this. Make this check, and otherwise do this recursion. And okay, I think that's a lot better. Yeah, let's do that and do the same thing again. Okay. Yeah, I'm not sure to what extent we need to sort of redo this work because we weren't recognizing halted states before. But we'll let it run like this. And I guess since we're reporting the numbers that we're on right now, it's going to be a little bit more possible than usual to make use of, say, another machine. To help us explore a little bit faster. So before I do this, I need to localhost like this. This should be localhost. All right, and then we'll say something like, oh, iterate by increment starting at like 500. Something like what we got here. Maybe we should start at like 1,000. Let's load all this. Okay, well, we don't need JSON here. Okay, we do need to take out this clipboard stuff. That's fine. And then, did we get this far into it? Okay, what's it complaining about? Line 51 here. Yep, that makes it a little bit more difficult. We would have to maybe copy the program over. Not the hardest thing in the world. Yeah, what kinds of values are we getting for over here? That isn't connected, then something like this. Excuse me. And then our implementation. And actually, let's machine also. It is getting all kinds of these other states. I wonder if it's necessary to. Oh, interesting. Interesting. I'm looking at this program and I'm wondering if it's necessary to like sort of analyze it, like you know, by looking. For now, I'm gonna assume that we can still do it this way. So I need a line seek of a IO reader on 10 code. Do I have Clojure Java IO? I do. All right, so on the remote machine, let's run this. Good. And then something like this. Oop. All right, it's cranking. Maybe even a little bit faster than my local machine here. Yeah. I wonder if we don't have a choice except to just wait. And I guess, let's see, what other sort of stuff would I want? I guess I would want to make sure that, like, so I know we're not running the same program every time, that the value of A matters. So let's see, A goes into D, 4 goes into C, a big thing. Yeah, what's happening with D here? D goes back into, okay. A gets copied around a bit. Here's the out. So here's where the out happens. So look at the problem statement. Lowest positive integer used to initialize register A for the clock signal. Either integer or the value of the register. Okay. Yep. It's going. Let's see. Under what circumstances could we make this process go faster? So we're doing the obvious thing of just running the computer. I wonder if we could maybe like figure out like run things in parallel maybe. I wonder where most of the time is being spent. Okay. Well, so let's try to decompile this here. All right. Still cranking. All right. So this set of instructions, I think, is understandable to us. So A goes to D, 4 goes to C, this gets B, and then I think we figured out that this whole structure is a multiply where, let's see, B equals, A plus equals B times C. And then B equals 0, C equals 0, D equals A. All right. Then A equals D here. JNZ 0, 0. So if 0 is not 0, then do a jump. Okay, so just a no op. Copy A to B. Copy 2 to C. ANZ, okay, that's another no op. Then B minus minus, C minus minus. All right. So this jump no 0, that's a no op. A plus plus, that's another no op. Then B equals 2, like that. Okay, that's a JNZ on C. That's not going to happen. Then another JNZ. It's not going to happen. Then B minus minus, C minus minus. So now C is 0, but then 2 JNZs that aren't executed. Oh, shoot. I gotta back this up. This is definitely a jump because it jumped non-zero. All right, so all right, so it's all good. See where's so copy D to A, then that's a no op. Copy B to A. Copy 0 to A. Like this. Copy 2 to C. Then potentially jump up 2, which is I think pretty much irrelevant here because the next instruction is oh no, the next instruction will happen. Yeah, that's hard. Let's take a look here. Okay, timing information. The only antenna. Yep. Okay. Just recently. Yep. Day 23. Got it. Either an integer or the value of register. So maybe I should look at. Because how do we get to out B? We basically need to be in a situation. So how many lines of code is this? All right. So if A is non-zero, then we go up 19. All right, to like there. And otherwise, our looping condition is going up 21 here. This is hard to analyze. Could we make the whole thing run faster? Maybe we could use a a transient set. Would that work? I don't know. Well, I guess where are all the things where B gets data put into it? So here, B gets set a value of 2. Then we might be jumping up off of this instruction here. So let's see. So B gets a value of 2. Then C gets a value. Then we potentially are jumping forward. That's fine. B might get decremented. That's fine. C gets decremented. Then potentially we're jumping up 4 here. So up to here. If C is non-zero, then jump like that. And then decrement it again. I see. I think I get it. So my understanding is that if C is 0, then well, I guess let's try this little block of code here. So it gets 2 if C is greater than or less than 0. Then go to, here we go, if C is exactly equal to 0, then we're going to do, and then output of this, output B. Then this block here gets executed if C is not equal to 0. This block. So in that case, we do B minus minus, C minus minus, and then something like go to start. Output B, and then, all right, so 19 up. So that means we go 19 up. So instead of start, I'll say this is like do output. And we'll have start here. Okay, output B. And then let's see, if A is 0, go to 21. Okay, so it's still going to be go to start. It's just if A is 0, B gets, A becomes D. Okay. Go to start. start is up here, and the implementation is b equals a, b equals 0. Okay, so seems like this whole thing, the whole point of jumping 21 up from the bottom here into this state. But if you copy D into A, but then you're just copying 0 into A, so it shouldn't even matter. So, okay, I'm going to say that doesn't matter. All right, then copy B into A. A is 0, C is 2. All right, then the next is if B 0, then do something else. So let's see, B is 0, and we're going to run these instructions, which is decrement B, decrement C, some other kind of jump. All right. All right. Jump non-zero B. Therefore, if B is 0, then execute these. Execute these rather. All right, so E minus minus, C minus minus. Mm-hmm. Mm-hmm. So it seems like it can't be the case that C can be 0. So I think we can ignore this. No, it's always the case that C is 0, which means, or the C is non-zero. So as soon as we're going 4 up here, this is hard to reason about. Mostly compatible uses one extra instruction as the next value for the clock signal. The code takes a value, you register A. Let's just make sure that we can recognize a proper ending state here. So let's write a program that will generate this. So the program that we're going to write is out 0, new line, out 1, new line, JNZA -2. And here, let's like this. then code is that. We'll just do so starting state code to be this thing here. And let's do until looping this. Lazy seek can't be cast to this should be map v. Uh-oh, that's not good. So that's not good at all. Because this should have done the right thing. Okay, update outpost by conj of that. Okay, the only thing that I can think is that it's got to be the case. So let's take a look at starting state here. Or I'll just here. State of A is 12. Okay, like that. Oh, that won't necessarily help me. Okay, maybe we'll just do, so all right, maybe we'll do this. Because it won't be halted. I know what we'll do. Okay, so let's take 10. Iterate do instruction on this here. And then let's just take the last one of these. Okay, where is the output? It says output 0, 0, 0, 0. But I'm outputting 1 here. All right, am I getting value, state, arg A of instruction? Output conj. Okay. Out 0, out 1. What's up? What if I just did this? Out 1, out 1. Okay. So it's saying what is it saying? Doesn't look good. JNZA -1. It should be going up 1 instruction. All right, where's the instruction pointer at? Instruction pointer is 0. Here, let's change this to just 10. Kind of big, but let's run it again. Okay. 1, 1, 1. Oh no, I know what I'm doing wrong. Oh no. Yeah. Shoot. Not incrementing the instruction counter. Okay, so all of this work was for nothing. Ouch. All right, well, at least we found it. Okay, so. All right, iterate int starting at 0, like this. All right, and then let's, okay, and then if we do this, okay, and then if we say this, And it looks like that output is looking good. And then let's run until looping on this. Right, until looping gave us true. Oh boy. Okay, so this doesn't guarantee that we're gonna get, yeah, but much better looking output here. Interesting. 32. Yeah. All right. I guess. Yeah, we might as well. In this REPL here, and then start it. Oh, I don't know, 500 something. Yeah, I guess now it isn't surprising that it's taking so much longer to run, because yeah, now we we aren't exiting the loop quite as fast. All right, looks like the remote machine is going a little bit faster. Maybe we can establish like a different REPL into it and start searching at a different point, like here maybe. Yeah, the exploration is pretty slow though. I think. Yeah, I think we might have to prune this here. So right now we're running every program until it outputs anything. I think we're gonna need to like make the program crash if its output is not matching. So, all right. So we say something like if crash computer value here, then emit alt, or emit this. No, how do we do this? Oh yeah, we can assoc in state I. Oh no, hang on. Assoc in computer state I to be the count of the code. All right, I think I like that. Now our crash predicate. All right, and then we got to do something like, okay, keys, this is going to include output, and then val. Okay, and then we basically say, if let x to be the last of output, then we're going to say if cond equals x1, then we crash if then the next val is not equal to 0. And similarly, like that, Otherwise, else we can crash if the next value is not 0. So this situation, I guess, greater than x1 true, less than x, or I guess next val. All right, so let's try. Okay, so can we establish another connection into this REPL? There it goes. All right, so let's try doing that, and then doing this. And will it? Okay, so yeah, that crashed it real good. So okay, so where's it at? 345. Key must be integer. So assoc in. Oh, okay. Okay. There. Interesting. Wait. It's saying that 1002 gives the right answer. Let's say it returns true. I wonder why we didn't hit it before. I don't know if I trust this. Maybe what we should emit instead is next state, something like this. Output is 0, 1. All right. Well, since 1002 does seem to be the right answer, let's try it. Not the right answer. It's too high. Okay. Fair enough. Let's try this starting at 0. So, two? Oh, geez. Is it actually 2? I wonder what it was that we fixed, if anything. Oh yeah, here's the output. All right, let's try 2. 4 seconds left. All right, 2. Not the right answer. It's too low. Okay. Well, so our output is correct, and we should be in a. So I'm pretty sure we're not in a halted state, but let's check. So halted. We're not in a halted state. Did I change anything? So I'll put everything back into the REPL here and it's not giving me any output here. Ouch. That REPL was pretty unresponsive. Still looking good. Here. All right, let's try this. It says 2. Did I change starting state? Maybe? So let's see. Somehow introducing this behavior, this changed it. So what if I just change this and say the crash is always false? And what happens when I say, oh, let's just take 10 of these. All right, so somehow my implementation of crash made, so this should have done, this should recognize that the computer is in a halted state because we are associating in the computer I to be count of the code. All right, let's put this back on. All right, and observe what happens. All right, so why? Let's say, okay. All right, so this should search a little. This should search faster now. Hang on. Am I recognizing this situation? So basically, if the next state is going to be halted, then we can stop. Yes, that's correct. Next state is one that we already know about. Yep. That's fine. Because what if the loop is happening on outputting 0? Yeah, I think what we got to do. I think we got to do it this way. Okay. Try this. All right. What is the deal now? This. Probably just a REPL thing. Need to. Okay, do that. This. All right. So this is not supposed to be commit this and Hmm. Okay, try it again. Then search. Easier to type in the folder. So 2 is getting returned. I guess let's emit this thing here because I'm very curious what it looks like. Okay, that's output. This output looks good. What's the state of the instruction counter? 27. It's in 27, so are we not recognizing halted properly? Is it because because it returns next state. So second return. Saying that is not halted. However, I'm pretty sure. Oh well, no. This is fine. I think this is fine. If I run this, let me. I guess let's just take this bit out here and let this run on 2. So search on 2. Just gonna run for a while, and then let's get interesting. Okay. Right. Yeah, my program is not. It's emitting 0, 1, and it's entering a loop, but that loop doesn't include the emitting of 0 and 1. Okay. All right. So how do I solve this? Hmm. Hmm. I could. So I know that it's got to be. I know that it's somewhere in the range. No. Ah. Maybe. Maybe I could mark the loop state somehow. How do I do this? I guess I could just find. So I know that it's in the left. So maybe I could just find the candidates. So let's say like this. All right, let's try something like this. So let me get candidates to be search up to 1,002. Count of candidates. Oh, wrong. Then I guess see, I need help searching here. So, okay, so loop it until, okay, so I want to say like let looped be something like this. All right. When we're emitting this state, then we want to say something like we want to like run this again. And then I think that'll be okay. So when loop 2, something like that. Associating starting state. All right, we're actually going to want to take starting state here, and then associating the output being like that. So reset the output, run it until it loops again, and then verify that it produced valid output again. And I'm just going to, so I'm assuming here that there's no more than, yeah, I think this is, I don't know, I feel like this should get us closer. Okay. So let this and first search starting at 0. Oh, right. We want to start looped, not touch anything. Better. Okay. All right, and running a little bit faster this time. And I guess no reason to leave the other machine out of it. Use REPLs here. So that's what I'm working with. And let's say first search starting at 100. We'll see how we're doing on the daily leaderboard here. Feels kind of slow today, but who knows? Oh, all right. Looks like people solved it in about 24 minutes. We're about 70 minutes into day 25 right now, but I'm feeling pretty good. That this is the last refinement that we'll have to make. Maybe I'll even since my MacBook's a little bit slow, can we get to this REPL? Where is it? Yeah, this is in my SSH section. I can say first search from 300 maybe. Here we go. So this is saying 198. Try 198. Right answer, rank 250. Okay, return to the day. Antenna's ready. All you need is 50 stars required to generate the signal. A lone star. You have enough stars to transmit the signal. Okay. Hey! All right. Santa was already waiting. Congratulations, you finished every puzzle. Hope you had as much fun. Love to hear about your adventure. Great. All right. That was a lot of fun. Highlighted. Okay. Pretty cool. Let's take a look at our advent calendar. Oh, awesome. Ah, that's great. And there's Santa in his sleigh, Rudolph at the front. Oh, I love it. All right. Well, this was a lot of fun. Yeah, just to quickly review the last problem here, it was essentially recognizing that the computer had entered a loop state that was going to be outputting, like you see here. Oh wow, this is actually outputting quite a lot of zeros and ones before it repeats. So yeah, my implementation was basically, we can stop this, was to write a simple loop here where we track all previous states. I wonder why. Yeah, so there were a few refinements that I needed to make. I think like I needed to recognize we'd gotten into, like, whether we'd gotten into a halted state for a long time. I had a problem with my output here where I wasn't incrementing I, the instruction pointer, when out got run. And then there was a program pretty early on where it emitted 0 and 1 and then went into an infinite loop that didn't involve emitting 0 and 1. So I put this in here. This is not actually correct because something could happen where it emits 0 and 1, goes into some kind of loop. No, wait, hang on. So emits 0 and 1, goes into some kind of loop, goes into, actually this might be okay, because this means that we're in a state that we've been in before, and then now what we're going to do is we're going to keep running it, and we're going to verify that we emit that same thing again. So yeah, that looks good. Yeah, that was pretty much the whole thing. Let's see where we ended up on the leaderboard here. 60th place, not too bad. 1,186 points there. I'm pretty happy with that. I'd like to congratulate everybody else that placed, or everybody that participated. We know that there were hundreds of them, and yeah, hopefully everyone learned something. Yeah, that was great. Let's just look at the completed calendar. Oh, perfect. Perfect. Yeah. Well, thank you for watching this Advent of Code series. I had a lot of fun making it. I'd like to thank Topaz, Eric Wastel, who for making this and providing us with all this entertainment. I'd like to thank my lovely Nancy, whom I'm going to be marrying next year, and who's been supporting me through this whole thing. And now it's Christmas Eve in California, so I'm gonna go join the rest of my family and have a lovely little Christmas together. So whoever is watching, I hope that you also have a great Christmas and a Happy New Year. And this was fun. This was my first foray into broadcasting and broadcasting my coding sessions. I think some people like it, and maybe I'll be doing some more of it. But for now, let me sign off. Once again, wish you a Merry Christmas, and thank you very much for watching. It was a pleasure to provide these videos for you. All right, thanks.